Welcome to this virtual training on how to set up and monitor a hemlock health monitoring plot. This project is a subset of Tree Species in Peril, which is headed by the Nature Conservancy. I'll start with some background on the overall project, then discuss more of the particulars of the hemlock health monitoring plot setup. We'll briefly touch on site selection, then discuss how to select and establish your plots within your site, and after that I'll talk about some of the particulars of data collection. But this presentation will not contain field demonstrations of data collection. You can follow along with where we are in the presentation using the bar at the bottom of the screen. This whole project is a subset of Tree Species in Peril, a project headed by the Nature Conservancy, but made up of a broad coalition of organizations working together. The ultimate long-term goal of Tree Species in Peril is to develop genetic resistance to pests in vulnerable eastern North American tree species through resistance breeding in these tree species. This project focuses on these 5 tree species. In the 3 ashes, there's already been some success with resistance breeding against emerald ash borer, and that's particularly true within green and white ash. With American beech, there had been a lot of progress with resistance breeding against beech bark disease when beech leaf disease came into the picture. So that portion of the project is kind of regrouping now and trying to figure out how to make progress against both pests. Eastern hemlock is where we come in. This is the youngest section. So research into hemlock resistance is very much in its early days. We don't even know what the genetic mechanism could be for hemlocks to exhibit resistance to the invasive pests that impact them. That's hemlock woolly adelgid, or HWA, and elongate hemlock scale, or EHS. So this piece of the project, which we are calling the Lingering Hemlock Project, is very much in its infancy. This is just a subset of all of the many people involved in the Lingering Hemlock Project. So you have different partners who focus on different things. Many of these partners participated in developing protocols to use to look for candidate lingering hemlocks. Then we have partners like the Holden Arboretum in Ohio, who are housing our experimental orchards. We have partners who are experts on tree breeding and partners who are working on app development for ease of data collection. So we're just one small piece of this broader ecosystem. I work for the New York State Hemlock Initiative, and what we're focused on right now is looking for partners who are willing to help us look for lingering hemlocks. Hemlock trees are primarily threatened by the hemlock woolly adelgid, or HWA. This is pictured here in the center. This is a zoomed in version, and if you see it in the field, it might look more like this. So this map on the left side here shows us the range of hemlock trees in eastern North America. So this lighter green color is eastern hemlock, and the smaller range in the darker green is the Carolina hemlock. Then on the right, we have that same range in that light green color, but this time with overlays of detections of HWA by county, which is current through the end of 2023. So you can see here that HWA is present through the full range of Carolina hemlock, and it's spreading and continuing to spread through eastern hemlock's range. The Lingering Hemlock Project ultimately has the goal of bolstering hemlock trees' genetic resistance to HWA through selective breeding. But in order to selectively breed hemlocks exhibiting some signs of genetic resistance, we would have to detect genetic resistance in the wild. So that's really step 1 of what we're looking for. And we call these hemlocks that are in the wild and surviving a little bit longer than their counterparts next to them, we call them lingering hemlocks. So lingering hemlock is a hemlock that's still alive when those around it are not, despite similar conditions. So this might look like one beautiful, healthy hemlock surrounded by dead hemlocks. That is something that some people have reported seeing, but it's possibly much more likely that this would look like a hemlock that's barely hanging on when those around it are dead. Either of those examples would be lingering hemlocks. Basically, we're just looking for hemlock trees that are unusually healthy. Once we find hemlocks that are unusually healthy, we'll investigate to see if that survival that they're exhibiting actually has a genetic component or if it's more abiotic factors. And then we can build on that once we've been able to find them. But first, we're on the step of really just looking for them. The threshold for that question of whether most of the trees around the lingering hemlock are dead is 80% mortality. So in areas where we are already seeing 80% mortality or higher of hemlock trees, we will be employing the lingering hemlock protocol. Basically what that looks like is there's an app that you can download. You go out into the forest in an area where 80% mortality or higher has already occurred. That's 80% mortality of hemlock trees specifically. And you would go ahead and just take a GPS coordinate and a photo and take some data on the surrounding hemlocks and their mortality level in that area. But in some areas, hemlock mortality has not yet reached 80%. That's where this other protocol that's our main focus today, the Hemlock Health Monitoring Protocol, that's where that comes into place. Basically, the idea here is to set up a network of hemlock plots throughout the range of eastern hemlocks where 80% hemlock mortality has not yet occurred. So these different plots would each be monitored annually to see how hemlock mortality is progressing in those areas. And then once that area reaches 80% mortality, we can pivot to using the lingering hemlock protocol to find the hemlocks that are still surviving when those around them are not. So these are kind of like sentinel stands. And essentially the goal of the Hemlock Health Monitoring Plot Network would be to track hemlock mortality as HWA is moving through the landscape. So now we'll kind of get more into the Hemlock Health Monitoring plots specifically and what setting those up and monitoring them looks like. Our Hemlock Health Monitoring Protocol involves these 5 steps. Basically, in year 1, you will need to complete all of them. You'll select an area to put your plots in called your site. You'll establish 1 or more plots. You'll set up your plots by tagging your trees. You'll do a brief survey of the dead trees that are within that plot, and then you'll conduct your annual survey where you collect data on the health of those trees, their crown health, the degree of hemlock woolly adelgid infestation and elongate hemlock scale infestation, etc. That's all year 1. We know that's a bit of a lift. But once you have established these plots in all of the subsequent years, the only step that you need to do is step 5, these annual surveys. And so we're hopeful that the biggest lift is really going to be year 1. And in the years after that, it will be fairly simple to participate and continue participation in this program. So let's get into site selection. This is a really, really simple step. This is not the specifics of your plot and the trees in it. This is really just the general area where your plot is and information about the permissions needed to access it and monitor it. This is what that data sheet looks like. Basically, you have to write the name of your site. You can get creative, but what would be more helpful is if you use this more boring but perhaps more informative format. You put the street address of the general site area, and then there's some questions about land ownership. So whether permission is needed to access the property, and if so, the name of the site owner, their email, and then if there's a different contact for the site for continued access, you would put that information as well. And that's really it for site selection. If you're here watching this video, you may already know the answers to most of these questions. This is just kind of the general information about where you're going to put your plots. That brings us to plot establishment, which is a little bit more complicated. In this step, basically what you're saying is, I know I want to put a plot in at this property somewhere, but where and how can I do that? So we'll start with some basic plot qualities that are necessary. The plots should contain 20 to 40 living hemlock trees, and ideally we really want that number to be 40 living hemlock trees. We have this range in here because we recognize that throughout the range of eastern hemlock there are going to be different qualities of areas where there are hemlock plots, and so if you're in an area where you can really only find 20 living hemlock trees to monitor, that is okay for you to monitor that plot instead. But if it's at all in your capacity, we ask that you please try and get this number to be as close to 40 as possible. We also are asking that you choose a plot in a stand that has not undergone and will not undergo chemical treatment. Basically, because the goal of this is to monitor natural ongoing hemlock decline due to hemlock woolly adelgid or HWA and elongate hemlock scale or EHS, Because our goal is to monitor that ongoing natural decline, we want to know that the trees that are surviving are not surviving because of chemical treatment. So just make sure that you're choosing to put these plots in an area where it's okay to not treat these trees, and where you may be choosing to watch them die over the course of monitoring this plot. And then finally, if you do decide to create multiple plots, the maximum number of plots per site is 3, and they should be at least 150 feet away from each other. You're totally welcome to create just a single plot if that's your capacity, but if you do decide to put in more than one, we just ask that the maximum be 3. And then, so now that you've chosen kind of your general ideas of your plot qualities, of where you want your plots to be, and where are good fits in your property, you're going to decide how you want to design your plot. This is going to be kind of like what orientation you might want to use for a plot. And there's a few different possibilities. We have different examples, different possibilities for plot design for the same reason as that range with the number of hemlocks. We want this to be applicable in a lot of different environments, and we recognize that there are going to be different characteristics that might make each of these plot designs more or less applicable. And some of the things that you might think about when deciding what plot design to use, you might think about your forest composition, the density of hemlocks, what the terrain looks like, or some other site characteristics. So first we've got a fixed radius plot. Basically what this looks like is you use a center point that's fixed. You might put some kind of permanent marker there. Sometimes people will use mark rebar. If you want to just collect a GPS coordinate or tag a tree in a particular way to mark that center point, that's also acceptable. It's really just what works for your own type of plot monitoring. But essentially you choose a center point that's fixed, and then you pick a radius that's necessary to incorporate 20 to 40 living hemlock trees. So some good forest types, some suitable places where you might want to use a fixed radius is maybe if you have a really dense hemlock stand, you might be able to have quite a small radius and really have a fairly accessible stand that's right there all neatly near each other. This also might be good for a relatively flat area because you'll be traversing back and forth through the plot. And so if it's on a really steep slope, this might be less applicable. But in a flat area with dense hemlocks, your fixed radius might be the way to go for you. Another option might be to anchor your plot to along a transect or a trail. Basically, in this example, you would have your anchor points at the ends. So you could mark a first point, then tag each hemlock on either side of the trail until you get to 40, when you would mark your end point. This could be also, instead of along a trail, you could do this along a transect through the forest. And this might be a good option for your plot design in areas that are a little bit less dense. So if you're having to go further distances, it may be easier to do so on a trail, or if your hemlocks are a bit more spread out, this might be a good way to choose which hemlocks to use. If you already have a trail that exists alongside hemlock trees, that could be a good example, a good way to design your plot. Another good example would be if you're putting in a plot along a very steep grade where you would like to go kind of perpendicular to that grade instead of up and down. This might be a good option either with a trail or with a transect. And then finally, if the folks who are going to be doing the monitoring, if there's any mobility issues or limitations in people's access, sometimes it's just simpler to have that on a plot. Finally, we have the shaped option. So this is really this can be less defined than a square or a rectangle. If you have some kind of blob area, you could certainly do that as well. This is basically in any plot that doesn't neatly fit into a fixed radius plot or a transect or trail plot, you can just create the shape that works for you. So essentially in this, you're going to choose your surrounding points, your boundaries of your plot, and then you tag the hemlocks that are in that. And that might be good in areas that have moderate hemlock density, or maybe in areas where a hemlock stand is bordered by other forests. This also can end up kind of describing some plots that are along a trail if there's hemlocks that go a little bit deeper into the forest alongside that trail instead of just those immediately on either side. Basically, the reason why it's important to pick your boundaries is so that then when you're assessing the mortality in that area, you know which trees to include and which trees to exclude. And so then in future years when you return, you'll know which hemlocks fall within that plot and which do not. So, okay, here we are. We've picked the general area, the site for our plots. We've established the boundaries of our plot. Now it's time to go through and set up that plot. Basically what that looks like is you're going to tag each tree that you plan to monitor annually. So each of those hopefully 40 trees. There are many different ways that you can do this. It's largely going to depend on the permissions from the site owner or manager if that's not you. So you're basically going to go through your plot and assign a number to each tree based on the tree tag that you affix to that tree or whatever manner that you're using. So there are different ways that you can tag a tree, different tags that you can use. Probably the most common version is this photo on the left. These are aluminum tags. You see these pretty commonly in forest plots, and they're fairly affordable and easy to use. One example of a place where you could find them is treestuff.com, but we have no preference for how or where you access your tags. That's just one example. One thing to bear in mind with these aluminum tags is they can be used to denote other types of forest management. And so depending on what the makeup is of your plot, if there are already aluminum tags in it, it might make sense for you to get something like these center tags that are a little bit more distinguished, just so that you can differentiate them from the aluminum tags if there are already aluminum tags present. And then if you're unable to or don't want to use or purchase tree tags, you can use tree paint to mark your trees. But something to keep in mind with this third option is that it can fade over time. And so you just want to make sure that you're on top of reapplication of those numbers to make sure that you don't lose track of your trees from one year to the next. So a couple of tips about safely tagging your trees. If you are using tree tags with a nail, you'll want to make sure that you use about a 2.5-inch aluminum nail to not hurt the tree. And then you want to make sure that you tag that at a slightly downward angle. That's basically trees grow over time, and so if you use this even perpendicular to the ground to the tree angle, your tree tag might sit right at the bark, and trees can actually grow over tree tags and kind of eat them. So by using a downward angle, you are assuring that that tree tag is going to rest by the end of the nail instead of resting against the bark, and that can prevent losing your trees and losing your tree tags as time goes on. This is a photo example of that. Another thing to bear in mind is not to sink your nail in all the way for the same reason. So then as your tree is growing, it won't eat the nail and the tag. You just want to sink that in until it's through the bark and just into the wood itself, and then that just gives your tree room to grow. And then finally, if you are using spray paint to mark your trees, just make sure that you use tree marking paint. There are specifically formulated tree paints that are less harmful to the trees. So now you've picked your tags, you're going to go through and select which trees to include. You want to make sure that you are tagging trees that are at least 4 inches in DBH. If you're not already familiar, DBH is diameter at breast height, and there are specific tools that are made to measure this that essentially do that math for you. You wrap this, this is essentially like a tape measure. You wrap it around a tree, and then on one side it has regular distance, which would correspond to circumference, and on the other side it has diameter. DBH, again, diameter at breast height, this has been standardized to 4.5 feet. So you're going to want to take that quote unquote breast height at 4.5 feet off of the ground. Something that you can do in the field is mark where a seam on your clothing is, that is about 4.5 feet above ground. And then that way, when you go into the field, you can estimate that diameter at breast height without having to measure it on each tree. Then you're going to take your tape measure or DBH tape, measure around the outside, and record that. If you do not have DBH tape and do not want to purchase it, you can instead just use a regular tape measure or transect tape. You just want to make sure that as you're writing that information down, you're very clear about how you've collected that data, so that then when you ultimately submit it, it's submitted in the way that we are asking for it, which is in inches to 1/10 of an inch. And finally, if you're measuring this on a slope, make sure that you're measuring that breast height 4.5 feet from the uphill side. So if a tree is on a slope, don't stand on the downhill side to measure 4.5 feet up, stand on the uphill side. Another thing to bear in mind as you're selecting trees is to choose trees that are generally representative of the forest condition. So within your stand, you don't want to high grade. You're not choosing only the biggest and most beautiful trees, and you're not choosing only the trees that look like they're about to die. It is okay if within one property there's an area that seems like those trees are in slightly poorer condition. It might make sense to situate your entire plot in that area, so that way you are likely to get information about which trees are surviving a little bit more quickly, and we won't miss out on any of the potential genetic signatures that give those trees an advantage in those areas. But within a stand, you want to make sure that you're choosing representative trees. So that's the summary of your plot establishment. And now I just want to go over the data collection and some particulars to keep in mind in your data collection process. You can access all of our data sheets on our website, which I will link to at the end. But these are some pieces of that data collection that you might need a little bit more background for. One question is going to be on the type of soil. So there's 3 different types that you can indicate. We have hydric soil, that's generally wet, and slow draining soil. So with hydric soil, there may be water at or even above the ground surface all year round, even through the summer. Another type is mesic. That's a more balanced moisture, where the moisture level is going to really depend on the recent rainfall. So generally, mesic soils are somewhat moist, but there's going to be a little bit more variation than with hydric soils, depending on when recent rainfall is. And then finally, we have xeric soil, which is dry. This soil might be quite moisture deficient in the summertime. Another question that will come up on your data sheets is gauging slope. So you're just estimating this, but we have some rules of thumb for the grade that would be associated with a flat or gentle slope, and etc. So we have these kind of triangles to show you kind of what a flat or gentle slope would look like. So this is up to 8% of a grade, and a good rule of thumb for estimating a flat or gentle slope is that about 5% slope is going to be about when you start to feel just a little tiny bit of tension, like in your ankles. So if you're just starting to feel that, or it's less than that, you might decide to put flat or gentle slope. A moderate slope is going to be a little higher, so it's going to be more than just a slight tension in your ankles and hamstrings. Steep slope would look like about this, this angle of the ground, so certainly a little bit more than moderate, but again, you are just estimating. And then extremely steep is going to be any slope that's above 35%. There are apps that you can download for free on a smartphone that if you set that phone on the ground, it'll tell you what % grade it is, if you want to be more exact than just estimating these. And with gauging slope, as well as some of these other options, there is the opportunity to write little something in the notes section about it. So for example, we've had some sites where there is a steep slope in some parts of that 40 tree area and a flatter, gentle slope in others. And so you can kind of do your best guess for what the majority of the site looks like, but there's also a comments section. And so you're totally welcome to do your best guess for gauging the slope, but then write in the comments, slope varies from flat, gentle to steep, or something along those lines. In your dead tree survey, which you will do once when you establish your plot, as well as in future years in your annual surveys if you're collecting data on trees that have died, there will be questions about signs of tree decomposition. So some ways that you can tell if a tree is starting to decompose is if the bark is peeling, if the wood is rotting, or if you see any fungi on it. So this is just to kind of give you a sense of how to tell. One other thing to keep in mind for your dead hemlock survey is sometimes it can be hard to tell trees apart from each other if they are dead, particularly hemlock and white pine, because if they're dead, you may not have those kind of telltale needles that are a little bit easier to tell apart from each other. So a couple ways to tell hemlock from white pine. First thing you're going to look for is the bark. Hemlock tends to have this sort of more brownish reddish bark, and after it's died and sometimes there's a little woodpecker damage, you might even be able to see more reddish than this photo from the underneath the bark after woodpeckers have damaged it a little bit. It also has these kind of longer, more vertical furrows. With white pine, it's going to be more on the grayish side, possibly a little bit darker, and it's going to have more of these kind of whorled patterns to it rather than these long furrows. Something else to keep in mind is branch spacing. So it's not always this stark, but with white pine, you'll often see these pretty evenly spaced whorled branches. And with eastern hemlock, it's a little bit more chaotic. It's a little bit less predictable. As you can see from this photo, this white pine is young. And so another thing that you can bear in mind is on a younger tree, white pine is going to have quite smooth bark when it's young before it reaches maturity, whereas eastern hemlock will always have those furrows even if it's a young tree. So that's something you can keep in mind too. Next, we're going to talk about different degrees of infestation. So there will be a question on your annual survey about the degree of HWA infestation. The options here are heavy, moderate, light, or none. So this is what a heavy HWA infestation is going to look like. All of these little white cottony masses are hemlock woolly adelgid. And so if you're seeing a heavy infestation, you're going to see one by nearly every, by the base of nearly every needle, if not more than one at the base of some needles, like you can see in this photo on the right. For a more moderate infestation, you can see here there are numerous little woolly masses, but certainly they're not at most of the bases of the needles. And then for a light infestation, it could be as little as just a single mass on a twig. And so that's going to be a lighter infestation. Anything greater than 0 is a light infestation, and then you can estimate kind of whether it seems more on the light side or more on the moderate side. You'll also be asked to estimate the degree of elongate hemlock scale, or EHS infestation. This pest can be a little bit more difficult to see because it's on the needles themselves, but you can recognize it by this kind of elongated shape, hence its name, and it's going to be on these needles. So this is an example of a heavy infestation. So we're seeing multiple scales on each of the needles. A more moderate infestation might look like this, where we have 1 or 2 scales on several of the needles. And a light infestation, it's difficult to see in this photo, but in this entire photo, there's one single scale. So similar to the HWA light infestation, it's really, if it's greater than 0, it's still an infestation. You'll also be asked to estimate crown health. And there are 3 different categories here: healthy, in decline, and severe decline. So for a healthy crown, it's going to be a pretty full crown of needles here. So one thing to keep in mind on some of these trees, especially if it's not in a super dense stand, you may still even see these needles at the base, on branches at the base of the tree. So that's a good indicator that that crown is pretty healthy. In a really dense stand of hemlock, sometimes they'll lose the needles on the bottom branches, not because the crown is declining, but just because it's shaded out by neighboring hemlocks. So another good way to tell this, if you're unsure whether the non-existent lower branches are due to lack of crown health or due to the situation in that particular stand, is standing underneath the tree and looking straight up. So basically, this is an example of a healthy crown where if you look up through it, you're seeing it's covering most of the light, most of the sky from above it. The next category in decline is a bit of a range. So that encompasses a lot of different kinds of crowns. This is kind of the high end of an in decline crown, where you can still see there's quite a few needles that are present on this tree, but you can see it's just not quite as dense as bushy as the one in the photo before. And then from underneath the tree, you can kind of see there's some of this light shining through, more so than you would expect in a healthy crown. If you look right in this area, you can see too that there are these really fine branch tips still that have lost needles. That's a telltale sign of hemlock woolly adelgid damage, where you can tell that these recently had needles on them, and so you can guess that decline is not just because those branches are being outshaded by neighboring trees. On kind of the lower end of this in decline category, in this photo on the right, you would look at this tree on the right. So here you can see there's kind of this grayish tinge, this grayish cast to many of the needles, but there are still quite a few needles present on that tree. This is also an example of where abiotic factors may be contributing to this tree hanging on because it's on the side of forest. There's quite a bit of light that looks like it's coming in from this side. And so just something to bear in mind, that some of these lingering trees may not actually have genetic resistance, but might just be surviving better due to those abiotic factors. That doesn't mean that you wouldn't still deem this an in decline crown, but just something to bear in mind as some context behind that. And then for a severe decline or dying crown, we're going to have the same photo, but we're looking at the tree on the right side instead. So with this hemlock tree, you can see there's many, many, many of the needles through most of its crown have died. There's still some of these fine twigs with no needles up at the top, but you can tell it's still alive because there are still some green needles at the very top. And then looking up underneath that tree, you can see all of this sky that's shining through where that clearly used to be covered by that hemlock's crown before it started to die. Finally, you'll be asked about canopy position when you go through your annual surveys. There's 3 categories for this: dominant, co-dominant, and what we're deeming overtopped, which is synonymous with understory trees. So this photo on the left and in the center, this shows a dominant and a co-dominant tree, where the dominant one is taller than all the trees around it. Co-dominant is nearly the same height and occupying a similar niche in the canopy, but it's just slightly lower. And then this photo on the right side shows you an overtopped tree, where it's very clear that every tree in this forest, or most of the trees around it, many, many trees, are quite a bit taller than it. So that's an understory tree. And with canopy position, there may be instances where you might want to fill in not applicable instead. So if a tree is more isolated than some of the others, or if it's on a forest edge and it's hard for you to compare it to the trees around it, you can write that. So that essentially concludes the data collection for this. You're going to go through, you select your site, you establish your plots, you take one round of data on the dead trees in that area, and then you go through, you tag your trees, and you collect your first round of annual survey data. We have prepared paper data sheets that you can print out to collect this data in the instance that you don't have cell service or that you prefer to take data physically. But if there's a way that you would like to do this by creating field maps or Survey 123 survey instead, that's completely acceptable. Eventually, we will have developed an app with some of our amazing collaborators that will help you collect this data without having to transcribe it. But in the meantime, we have a bit of a clunky data submission process. First, you're going to go out with your paper data sheets and take all this data in the field, or if you have a better way, such as using Survey 123, you can do it that way. Either way, once you've collected that data in the field, we ask that you transcribe it into our digital data sheet, also available on our website. And then you would email that to statinlabapps@gmail.com. So if you go ahead and set up a plot, and you collect that data and you transcribe it and you send it to this email right here, we ask that you please also copy us just so that we can keep track of where we have Hemlock plots, so that we know where we're hoping to set up new plots to fill in our monitoring plot network. Thanks for watching this. I'd be happy to take any questions if you submit them to my email, which you can find here. And if you scan this QR code, that will take you to our website. That should contain all of the information we have here. It'll have our data sheets that you can print out for use in the field. It'll have descriptions of our protocols, and it also has our digital data sheets where we ask that you transcribe that data and send it to statinlabapps@gmail.com. Thanks so much for watching.